Lesson P2. This is much more review, I think, than maybe some of the first lesson. Cartesian coordinate system. Now, if you look at that and you say, what the heck is a Cartesian coordinate system? You know exactly what it is. Cartesian's coordinate system is your graph here, right?
Why are they going to come up with such a complicated name?
That's always been the complicated name of it. It's, you know. So, Cartesian coordinate system. So when you hear Cartesian coordinate system, no, it's also called the rectangular coordinate system. But even when I say rectangular coordinate system, I feel like you guys are going to look at me like, do I know that?
It's not that complicated.
Okay, but it's what you know, guys. Okay, it's what you know. So, as you look at these two lines, what do we know about these two lines?
One
X and
goes
Y.
up and one goes down or sideways.
Okay, which one goes which? What are they called?
The X and Y coordinates, lines, axes.
Okay.
You were close.
Lines.
So we have the x-axis, which is horizontal. We have the y-axis, which is vertical. Okay. What about in these ordered pairs over here? What's the order in an ordered pair?
X and then Y.
X and Y. And when we get down to the end, we're also going to talk about what quadrants these ordered pairs are in. Do you remember your quadrants?
A, B, C, and D.
1, 2, 3, 4.
1, 2, 3, 4.
Be serious with me, Noah.
I thought that was, I legit like.
Okay. So I guess I just realized I just labeled quadrant 1 for you, and I was going to ask you. Okay, 1, 2, 3, 4. Where's quadrant 1?
1, 2.
Okay, so there's 1, top right. That's our positive quadrant. Where's 2?
The left.
Isn't that
Down, left.
Oh.
Bottom right.
Oh. What?
There's 2. Where's 3?
Bottom
And where's 4?
Let's remember.
Okay. Roman numerals is typically in quadrants. I'm not saying you have to number with Roman numerals. You can use regular 1, 2, 3, 4. Roman numerals is typical to be done when labeling quadrants. Okay? I don't care what you use. So, okay, let's practice plotting here. How do we plot negative 5, 8?
Over -5.
Okay. So, negative 5, the first number takes us left or right. Since it's negative 5, we're going to go left 5. The second number takes us up or down. Since it's positive, we're going to go up. So my coordinate of negative 5, 8 is somewhere up there. I'm going to label it A because it is point A. And what quadrant is point A in? That is in quadrant 2. We're going to go ahead and answer those questions while we're there. Okay, 0, negative 2. How do we graph 0, negative 2?
What quadrant is it?
0, negative 2, how do I graph that?
No X, you just go straight down.
Okay, left to right 0, down 2. I'm going to call this point B. What quadrant is this in?
Isn't it in both?
No.
No.
It's on the y-axis.
Okay, it's on the y-axis. Is the y-axis a quadrant? Technically, no. I mean, I'm not disagreeing. It is on the y-axis. In terms of what quadrant is it in, it's not in a quadrant. So you can just say none. You can also say the fact that it's on the y-axis. Both are true points. C, 5, negative 3. Where's 5, negative 3 take me? Okay. Right 5, down 3. I'm calling that point C. What quadrant are we in? Quadrant 4. This is old news, right? I can go as fast as I want here. 4, 0. Where's 4, 0? Right 4, up or down 0. That's going to be point D. What quadrant is that in? It's not in a quadrant. If you want to specify where it is on the x-axis this time. Negative 3, negative 2. Left 3, down 2. That's point E, and point E is in quadrant 3. And 3.5, 7.5. Quadrant 1, we're going to go right 3.5, up 7.5. I think I got that in the right area because I think that other number was 8. And that puts me, as we said, in quadrant 1. Okay, that's your review. Yes, we're good. Piece of cake. Been doing that for years. We're going to talk a little bit about absolute value. And interesting enough, we have this absolute value definition. Okay? What do you guys know about absolute value?
It makes a number positive, no matter what the number is.
Okay, so you put absolute value bars around it, around something. It makes that quantity inside positive. If it's already positive, it stays positive. If that quantity is negative, it becomes positive. Do you remember the definition of absolute value?
Yeah. The absolute value away from zero in the number line.
Okay, don't use the word absolute value in the definition of absolute value, but it's the
the thing.
yeah distance from 0.
Oh.
Okay, so like that's why its absolute value is always positive, because it's a distance. And do we talk about negative distance? Did you drive negative 50 miles? No, you didn't drive negative 50 miles. We have positive distances. So it's distance from 0. Now, what this is saying, if A is greater than 0, so if A is positive to begin with, then the absolute value of A is just itself. Make sense? Okay. This one says, okay, if A is less than 0, so if A is negative to begin with, then what is the absolute value of A? It's listed as negative A here, but think of it as the opposite, right? So if it's already negative, when you do the negative of A, it makes it positive. And then if A is 0, the absolute value of 0 is 0. Okay, so look at these. Evaluate. So straight bars, absolute value. What is the absolute value of negative 4? 4? Because negative 4 is a negative, and that is a negative value, so we want to make it positive. Okay. What is the absolute value of pi minus 6? Take a guess.
Negative 3.14, but you'd have to make it positive, so it's big.
Just say
Pi.
Not going to be exactly that, is it?
No, it'll be less. You gotta give me a second.
Okay, so I have an expression for my answer, so to speak. And that's why I was trying to figure out if you are equivalent.
it would be equivalent, wouldn't it?
Actually, that's what I'm
There's no
thinking.
pi button?
Yeah, there is. It's the second function of something on your right. Of the division bar, maybe? No.
Oh, it's
Of
like
the
the little
exponent.
carrot thing.
Yeah.
Oh, okay.
Yeah, so pi button. It is there. You just have to find it. It's the second. You have to do second, and then it's right above the caret, your exponent button. Yeah, no, it's not going to be equivalent to pi. That's what I thought.
No, okay.
I had
Be
to
a little
double check.
less than pi.
Yeah.
Well, not really less than, but like, you know what I'm saying.
It would be less than pi. Now,
I hope you know.
However, I'm going to take this a slightly different route. I'm not disagreeing. Okay, it is a value less than, a little bit less than pi. I'm surprised no one just told me pi plus 6 here. That's what I was waiting on. Okay, but if we say this is pi plus 6, all you're doing is making the subtraction sign positive, and you're changing the value of this, which we don't want to do. Okay, now I think what Kylie was doing, Kylie, did you try and mentally say, okay, what is pi minus 6?
That was the problem. I did it mentally. That didn't work out.
Okay, so if we do what is pi minus 6, it's a negative value, yes? And so then she just took that and made it positive, just slight calculation off. I'm following, okay?
Cool.
Now, here's what I would suggest. Can we agree that if we talk about the value of pi minus 6, without even picking up the calculator, is pi minus 6 positive or negative?
Positive.
Pi minus 6?
Oh, negative.
If you have pi and you subtract 6, you're going to be negative something, yes?
Yes.
And I don't even have to know what that negative value is. That was a horrible little symbol. Okay, so here's the deal. That what is inside the absolute value is negative, correct? So what do we do when the value is negative? What did it say here? If a is less than 0, so if my value inside the absolute value of ours is negative, we're going to do the opposite. So basically what we need to do is we need to do the negative of pi minus 6. Now, when I say the negative of the quantity of pi minus 6, basically take that negative and distribute it. And so this is equivalent to saying negative pi plus 6. And that's what I'd be looking for as an answer there. Are we okay with that?
Sure.
Sure? Yes? Okay. So, in other words, my point on B, I'm not going to pick up the calculator, just like I'm not going to pick up the calculator on C. Absolute value of square root of 5 minus square root of 2. Well, the first thing I'm going to ask myself, square root of 5 minus square root of 2, is that a positive or a negative value? Positive because why?
Square root of 5 is bigger than the square root of 2.
Okay. Square root of 5 is bigger than square root of 2, so a larger amount minus a smaller amount is going to result in a positive amount. Are you tracking what I'm doing there? Just taking us a moment. Okay. So if that is a positive amount, what is the absolute value of a positive number? Or positive value?
That number.
What?
Less than 2. Oh.
No. It's just that number, yes?
Yeah.
Okay. So here we're doing the absolute value of a negative number. Now I'm doing the absolute value of a positive. Well, the absolute value of a positive is just itself. So my absolute value here is just square root of 5 minus square root of 2. A little bit different way of thinking about absolute value, isn't it? But the big thing to walk away from is absolute values is not say, oh, there's a minus sign, I'm going to make it positive. That's what I need you guys to make sure you don't walk away from. Okay? Okay. Distance formula. You've done this before. I taught this in middle school math for years.
We did it in geometry too.
Okay, see? You've even done it more recently. See? More recent than middle school math. So, given two ordered pairs, x1, y1, and x2, y2, we have a distance formula. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's the difference between two ordered pairs. Now, there's also a second definition here that we don't think about as often, and that is just the distance between 2 points on a number line, which in order to do the distance between 2 points on a number line, we usually just subtract them, right? And that's what this is saying, is that you subtract a minus b, and it's the absolute value. I always just think subtract bigger minus smaller, but you know. Okay, let's practice. Let's find the distance between 1, 5 and 6, 2. Can you do it? There's my help, a big old square, empty square root. So x2 minus x1. What am I subtracting here?
1 minus 6.
Okay, Noah says 1 minus 6.
Oh, 6.
I'm with Natalie. I would have said 6 minus 1. Now, here's the deal. Doesn't matter. No. Noah can do Noah. Natalie can do Natalie. It's fine. I tend to go bigger minus smaller on my first one. It doesn't matter, though. So if I say 6 minus 1 squared, here's the D. Did I get my x values? Okay. So 6 minus 1 squared plus, now what about my y's?
Do I have to do 2 minus 5 now? To 1?
Technically, I am supposed to teach that you need to do 2 minus 5 because we want to keep the same order. And in some cases, in some type things like slope, it matters. in all honesty, it doesn't matter here because I'm going to square this value. So it honestly doesn't matter which you subtract first. Okay, you don't have to be consistent here, but then when I get to slope, I'm going to say you do have to be consistent. So if you're someone that's going to get it confused, just stay consistent. Okay, did you do the math? 6 minus 1 is 5. So we're going to have 5 squared. 2 minus 5 is negative 3. So I'm going to have negative 3 squared. So I have the square root of 5 squared plus negative 3 squared. So I'm going to be doing the square root of 25 plus 9. What's this going to work out to be? Good. Square root of 34. Depending on what they want, you can leave it like that. Realize you cannot say, oh, it's the square root of 25, the square root of 9, and then add those. You have to do what's under the square root first, and then take the square root. So you could leave it as square root of 34, or you could possibly get a decimal answer, right? I have written down in my notes that the decimal answer is approximately 5.83. And square roots, you guys will use these calculators. Square roots, just similar to your scientific, it's the second function of the x squared button. Okay, so it's there.
What are the letters for? Is that when you hit the alpha button?
Yeah, we'll use them another time. Okay, now distance. Find the distance between negative 7 and 19. I don't know, do you need a formula or can you use logic to do that? How far apart are negative 7 and 19 on a number line?
Very far.
Farther than 12.
26.
26? Because if I'm going 19 to the right and 7 to the left, it ends up being 19 plus 7, doesn't it?
Mm-hmm.
Now, what's the formula up here say? Officially, the formula says it would be the absolute value of, you could do this either way, 19 minus negative 7, or the absolute value of negative 7 minus 19. Either way, here it's the absolute value of 26. Here it's the absolute value of negative 26. Either way, it ends up being 26, yes?
Makes sense.
Okay. Yeah, don't just subtract them, though. Well, we did subtract them. 19 minus negative 7. Pay attention to negatives. Is that what I should say? I don't know. Okay, that was distance. Midpoint. We, same time you learned distance formula back in middle school, you learned the midpoint formula. Midpoint formula is given two ordered pairs. Where's the halfway point? And basically you're averaging the x values and averaging the y values. Okay? If you're just doing midpoint on a number line, then you're just averaging those two numbers. Midpoint is all about averaging. So we do our first midpoint. The midpoint when endpoints are negative 5, 2 and 3, 7. Well, what am I doing for my x midpoint? Negative 5 plus 3 and then divide by 2. What am I doing for my y midpoint? Two plus 7, divide by 2. And then it's just clean it up. Negative 5 plus 3 is negative 2 divided by 2 is negative 1. 2 plus 7 is 9. 9 divided by 2. What are my options there? 9 divided by 2 is 4.5, 4.5. I left it as 9 halves. So I would be happy with negative 1 comma 9 halves or negative 1 comma 4.5. I mentioned 4.5, but you probably shouldn't leave 4.5 as an answer at this point. Okay. Midpoint of negative 6 and 9. Well, That's just what's halfway in between those two numbers. And so if we're doing that midpoint, then it's just add and divide by 2. I don't know that you ever really taught that midpoint formula, just like I don't know if you ever really taught the distance formula on a number line, but it doesn't hurt to talk about it. -6 plus 9 is 3, divided by 2, 3/2. Or if you prefer, some of you have an issue with 3/2, and so you would automatically go 1.5. Okay, I'm not going to get quite as far as I'd hoped. Top this next page. Standard equation of a circle. Now, second semester, we spend time talking about our conic sections, which are the parabolas, the ellipses, the hyperbolas. Okay, I know those words don't mean a whole lot to you right now, but we'll talk about those shapes later. Right now, you need to be familiar with standard equation of a circle, which is what we have right here. X minus h squared plus y minus k squared equals r squared. Well, if this is a circle, realize what does the r stand for? R is the radius, so your equation always equals the radius squared. And the h and k form an ordered pair, and they are the center of the circle. Okay, so h and k are the center of the circle. That is the information you need to be able to use to just be able to recognize, because if I give you a standard form of a circle, you should be able to pull out the center of the circle and the radius of the circle for me. So right here on A, find the standard form, I have the center of 4, -1. Well, where are 4 and -1 going to go in my equation? Those are going to be h and k. A radius of 8. Where does the radius go? In for r. Can you set up that equation now? Instead of x minus h quantity squared, I'm going to say x minus 4 quantity squared. Plus, instead of y minus k quantity squared, I'm going to say y minus -1 quantity squared. And equals r squared means it's going to equal 8 squared. Now, that's just me solely filling in the pieces. The cleanup steps I would take. I'm not going to square it out because that would involve FOIL and that makes it not easy to read. But so I would leave this as x minus 4 squared plus y. What do we know about minus -1? So y plus 1 quantity squared equals, I would go ahead and square this, 64. That is how I would leave a circle equation. So when I look at that, I can easily pinpoint, oh, it's a circle because it's the two pieces being squared, x value 4, y value -1, radius 8. Okay. What about B?
Same thing.
Same thing? Difference, my h and k are 0 and my r is 5. Now, I would never leave what I'm getting ready to write as a final answer, but if we go with what they give us, x minus 0 squared plus y minus 0 squared equals 5 squared. Definitely do cleanup here. What is x minus 0 squared?
6.
It's x squared plus y squared equals 25. And so now, when I just glance at that, this is me as a math teacher, I know, okay, hey, that's a circle centered at the origin, so centered at 0, 0, radius 5. Okay. Example 5. I know, Belle's getting ready to ring on me. What did we talk about that involves distance today?
Absolute value.
Absolute value. So the distance between x and -3 So in order to do the distance between x and -3, you subtract them, kind of like that distance formula, is less than 9. We can talk a little bit more about that tomorrow. I would write that as x plus 3 less than 9. Only thing I didn't get to are these two big ones at the end. Do me a favor. Do your homework. It's probably all but the last two equations, or last two problems. Does that make sense? Because if I had to guess off the top of my head, it's the last two. So do your homework. Well, it's not the last two. What is it? 38 and 40, I think, are the two you can't do. Am I making any sense? Yes. I was going off the top of my head. It's usually the last two in this situation. So do your homework. It's all even. 38 and 40 are the last two. So are the two that you can't do. And I hope Noah will.
Maybe he'll figure it out, maybe he won't. We'll find out.
I don't know.
Homework due tomorrow?
Yes, plan on it being due. I mean, we'll talk about 38 and 40, but plan on it kind of being due tomorrow, if that makes sense.